Hello, I'm Mr. McBrien. This is TIJ10, Arduino 4, Serial Monitor. Yesterday we talked about loops and variables, and in fact there were a few things that were kind of frustrating about looking at those variables. We didn't have the capacity to see what we were doing with them because the Arduino doesn't come equipped with a screen like a normal computer would. Now today what we're going to do is we're going to dig into the idea of working with the computer screen while the Arduino is connected to it. Remember, it won't always be. This isn't its default configuration, but when it is, we're going to learn how to work with the computer screen. This is going to help us to learn about coding, but it also helps us to debug the things that we code. So the screen itself, remember, it's not part of a normal Arduino implementation. The computer screen is simply something we use while we are coding Arduino sketches. Because of this, because it's not the default part of the Arduino kind of struggles to communicate with users. And when you need to know what's going on inside that Arduino, sometimes it can be very confusing. And that, of course, is when you're coding, is when you really truly need to know what's going on. So we have an advantage though. While most or almost all Arduino applications have it detached from the computer and running on batteries, for example, when it's running along on top of a robot, controlling the robot. When we're coding it, we usually have it plugged in. We have it plugged into the computer, and the computer has a monitor that we can actually access from the Arduino. So we use a Serial.print command to communicate to the user using the serial monitor, and we can use a similar command, the mirror image of it, a Serial.read command, to accept inputs from the user while sketches are running. Now what we'll do from here on is we're going to incorporate a lot of these print commands to help us figure out what a sketch is doing, especially before we compile our final version of that sketch. Now, so the serial monitor commands, of course, have their own syntax, just like any computer commands. And this one, the Serial.begin command, is the one that'll give us the most trouble early on. But don't worry, it's really pretty easy to get used to using this. So there's a Serial.begin command to open communication. We almost always use it in this form. Opening communications with 9600 baud rate communication. The Serial.print command, I already alluded to this. This allows us to print to the screen. And we can print variables or strings to the screen very easily. Serial.read is accepting information that a user might type into the serial monitor using their keyboard. Serial.available is just a simple indicator that there's information available. Okay, there's other commands we'll talk about. So these are absolutely critical to our success in learning to be a programmer with Arduino. But before we start that, we have to learn how to actually view the serial monitor. You've been playing around with the code and you probably haven't even realized that there's this additional view that's available to you. So to view the serial monitor, it's different for every configuration that you're coding from. So you may have to do a web search to find the precise command. But from the Arduino IDE and PC, the commands to get to the serial monitor are clicking Tools and then Serial Monitor. If you're using the simulator in Tinkercad, there's a button at the bottom of the screen, but only after you've opened the code. So you can access the serial monitor after you've clicked Code, and the serial monitor button will be down below there. Now, I alluded to this earlier. There is a small challenge with using the serial monitor that sometimes gives us a bit of a snag. If you want to use the serial monitor, you have to open communication. Arduino doesn't default do this. So you have to say inside your sketch that this sketch is going to be one that communicates with the serial monitor. So in your setup, you'll just include this command. And I'd encourage you for the rest of this course to simply get in the habit of putting Serial.begin 9600 inside your setup. And if you do this, you'll never have error messages popping up associated with trying to communicate with the serial monitor. So the good news here is this one command opens communication both from the serial monitor to the Arduino and from the Arduino to the serial monitor. Okay, if we want to output from the Arduino, say when we're trying to monitor our sketch and see what's going on inside it, there are two commands we use. The first one is Serial.print, which just simply prints the contents of the brackets to the serial monitor. And the other one is Serial.print line. And this is just to make the text that you send or the messages that you send easier to read. It starts a new line and then prints the contents. So we might do a trick like Serial.print, you entered, and then user input value. Now, you can, in this case, user input value, of course, is a variable, so it's printing the contents of a variable. But the line above it merits some discussion. Because we put this in quotes, it'll just print the contents of the quotes exactly. So, for a little bit of practice, try experimenting with the serial monitor output and modify your blink code. So along with each execution of the loop, you want to use Serial.print line to output blink to the monitor. And don't forget that you need to include that Serial.begin command up in the setup. Okay, now at least as important, but slightly more complicated, is the idea of accepting user input to your sketch. Now you might do this if you wanted to have several modes that you run and the user chooses which ones. You might have this if you wanted the user to be able to turn on one device and leave the others off. Or you might just have this as a debug tool, allowing the user to put some input in. For example, if you have a flame sensor and you've incorporated a whole lot of code to do with a flame sensor, you might want to execute whatever fire suppression system you have or what have you. Execute that, yes, if the flame sensor goes on, but maybe also offer the user the input to trigger it themselves while you're developing it, so that you don't have to have a lighter out all the time. That kind of thing. So it's a debug tool. So Serial.read will accept information from the send window in the serial monitor. And there's another command we'll talk about in a second. But we have to also, if we don't want to waste a lot of resources trying to get information all the time and finding it's not there, remember the Arduino can execute its loops many, many times faster than the user can input values into the serial monitor. So we also need to put in a small statement to have the Arduino wait for the results. So the Arduino can wait for the user to put in information by putting a special loop in place. When you want to wait, you have access to the information about whether the user has put the information in yet with this little device called Serial.available. As soon as something has been input to the serial monitor, the value of this thing will switch from 0 to 1. This is very important. So as long as that thing is 0, there's nothing for your algorithm to collect from the serial monitor. So we have this special command, while, and this should not be a capital on the W there, while Serial.available is 0. And then you put the brackets and make those brackets empty. What it says, what this really means is just wait until the user has put information into the serial monitor. Okay, so if we don't then want the Arduino to do anything until some information has been put in by the user, we can have something like this. While Serial.available, double brackets, and then it'll sit and wait until there's something available. As soon as it's available, it'll push that information from the Serial.read into, in this case, our user input variable or user input value. So this simple sketch then, all it does is echo back what the user entered back onto the serial monitor and print it back out for you to see. In this case, we use the character command, so it'll only accept characters. But the key point here is if you want the Arduino to wait for something to be available from the serial monitor, you implement this little command right here. Okay, so now what we have is a really interesting capacity. We can have a sketch that won't start until the user puts something into the serial monitor. So it'll just sit and wait. And that's what I'd like you to build right now, is take your blink sketch and adapt it so that it uses our while command and waits until the user puts something in the serial monitor, then starts to execute with blinking. Okay, so the serial monitor can do more with the values than just start because something's available. We can, in fact, use another command and automatically register something that comes out of the serial monitor as an integer we can then use in the things we do. For example, allowing a user to specify how many times an LED should blink. That kind of thing. So to do this, we use Serial.parseInt. And all this is another way of reading from the serial monitor, but in this case, we're only going to accept integers. So this little snippet of code here will start up the Arduino, configure pin 13, open communication to the serial monitor, and then wait for the user to put an integer in. And there's nothing here about what the integer is going to be used for, but we can imagine it might be something to do with pin 13 and some device attached to pin 13. If you want to implement this, though, don't forget that this user input value has to be declared up above as a variable. If it's not declared, we're going to see that familiar error message of undeclared variable. Okay, so maybe that's enough for today that you can start doing some coding. Hopefully we've given you enough motivation and enough tools to be able to use the serial monitor effectively. When we want to open communications, we use Serial.begin 9600. When we want to write to the serial monitor, we can use Serial.print and Serial.print line. When we want to read from the serial monitor, we can use Serial.read or Serial.parseInt. And if we want our Arduino to not do anything until it's received information from the user, we just simply use this while Serial.available command to wait for the user to be ready. Maybe that's enough for today. For your homework, don't forget to do your exit card, and there's a new print to the serial monitor assignment where you do a countdown to a rocket launch. Here's the references from today. Thanks very much, and have a great night.